Dear students, let's continue with our discussion on nitrogen containing compounds. We were solving questions on identification of nitrogen containing compounds. Let's continue with the discussion on identification of nitrogen containing compounds. The 67th question. Identify X, Y and Z. We have a cyano compound 1, 2, 3. Right? So it is a propane nitrile or ethyl cyanide subjected to reduction with a very strong reducing agent lithium aluminium hydride. Gives you X. X when made to react with nitrous acid gives you Y. Y on heating with copper will give you Z. It is not a very difficult pathway. Okay? Let's analyze this and then we will start writing down the sequence of reactions. Now this being ethyl cyanide or propane nitrile, you have the nitrile group here. The nitrile group on subjecting to reduction with lithium aluminium hydride gives you what? Gives you a primary amine, CH2NH2. Because it is an aliphatic primary amine, it is made to react with nitrous acid, which is sodium nitrite and hydrochloric acid, but the temperature has not been mentioned. Only for aromatic diazotization reactions will we include temperature which is 0 degrees Celsius. Right? Because in the case of aliphatic reaction, the aliphatic diazonium salt cannot be isolated even at that low temperature. Right? The diazonium salt is unstable. It decomposes, releasing nitrogen gas to produce Y, which has to be an alcohol. So from CH2NH2, we get a CH2OH, which is a primary alcohol. Right? Now the primary alcohol is subjected to heating with copper. Now this reaction you have come across in the chapter aldehydes, ketones and carboxylic acid in the context of preparation of aldehydes and ketones from the corresponding alcohols. So primary alcohols on dehydrogenation in the presence of copper at high temperature will give you an aldehyde. Secondary alcohols also undergo dehydrogenation under these conditions to give you the corresponding ketone. What about tertiary alcohols? They undergo dehydration under these conditions to give you an alkene. So this we don't require those informations here, but just trying to make you recollect the context where you have come across the reaction where you're heating with copper at this specific temperature. Alright, so now we have an idea as to what X, Y and Z could be. Let's start writing down the reactions. So we start with propane nitrile subjected to reduction with a very strong reducing agent lithium aluminium hydride to give you the corresponding primary amine. C triple bond N is reduced to CH2NH2, which is X, which is 1, 2, 3 propyl amine or propan 1 amine. That when subjected to nitrous acid will give you the corresponding diazonium salt, decomposes to give you the corresponding primary alcohol. So CH2NH2 is now converted to CH2OH, propyl alcohol or propan 1-ol. The propan 1-ol is a primary alcohol on subjecting to reaction with copper at this temperature will undergo dehydrogenation. So 2 hydrogen atoms are lost, which will result in the formation of an aldehyde CHO propanal. Okay, so propanal is the identity of Z. The next question. An organic compound A has a molecular formula C7H9N. It forms a clear solution when dissolved in aqueous potassium hydroxide solution and benzene sulfonyl chloride. Now before we read the entire question, let's analyze each point. Okay? So we're focusing on what could be A. The moment you see benzene sulfonyl chloride, you should think about the Hinsberg's test used to distinguish between primary, secondary and tertiary amines. The indication whether it is a primary, secondary or tertiary amine is given by this information. Once the product you get when you react this nitrogen compound with benzene sulfonyl chloride, that product is found to dissolve in aqueous potassium hydroxide solution. Now this observation holds good only when the compound is a primary amino compound. Alright, a secondary amino compound will react with benzene sulfonyl chloride, but the product will not dissolve in potassium hydroxide because that product does not contain an acidic hydrogen. All this has been discussed in detail in the curriculum requirement of this chapter. Alright, a tertiary amine will not react with benzene sulfonyl chloride because there is no hydrogen on the tertiary amine. Right? So that is why we can conclude that this has to be a primary amine, right? The primary amine that comes to your mind could be an aliphatic or aromatic. Just because the number of carbon atoms is 7 doesn't mean that it is aromatic. How do we conclude whether it is aliphatic or aromatic is given by the next information. A on treatment with sodium nitrite hydrochloric acid at 0 degrees Celsius. The moment you see this temperature, you can conclude that A is an aromatic amine because only for an aromatic amine, the intermediate can be isolated at this temperature. And then with 2-naphthol or beta-naphthol forms an intensely colored compound. So this second point involves a diazotization reaction of the aromatic amine. So if this is an aromatic amine, you will have benzene ring with an NH2. That takes care of only 6 carbon atoms. Where does the 7th, so what happens to 7th carbon atom? It will be a part of an alkyl group. Let's see. But by the way, in this particular point, what you've got to understand is here a benzene diazonium salt is formed, which will undergo a coupling reaction with beta-naphthol to give you a red to give you a colored, intensely colored azo dye. Okay, moving on to the next point. A on treatment with, so now we know that A is a primary aromatic amine with acetyl chloride. Now why do we use acetyl chloride? In order to inhibit the activity of the amino group, right? We get the corresponding acetanilide. Now the last information will let you know what the position of that side chain would be. Followed by electrophilic substitution. So we have acetanilide followed by electrophilic substitution yields a single substitution product. So let's write all these reactions and then we will get to know what the final identity of A is. Alright? So reaction with benzene sulfonyl chloride and the product dissolves in potassium hydroxide indicates that A is a primary amine. Aromatic or aliphatic, we don't know until we know that it reacts with sodium nitrite hydrochloric acid at 0 degree Celsius. Fine. Now this is the reaction that you have learned, the Hinsberg's test. The primary amine with benzene sulfonyl chloride, a HCl is lost. The salt you get here will be soluble, the sulfonamide will be soluble in potassium hydroxide because of the presence of this acidic hydrogen atom. Alright? Now, the next one, the reaction of diazonium salt. So this is your amine. It produces a diazonium salt N2 plus Cl minus, right? N2 plus Cl minus. This on treatment with beta-naphthol. The hydrogen and chlorine will be lost as HCl and you get the product azo dye. The coupling reaction is involved here. Reaction with acetyl chloride. Okay, so I have not spoken about the CH3 group yet. This will give you the corresponding acetanilide, right? And the fragment remaining after we write down the structure of aniline is CH3. Now, where do we place the CH3? To identify that, let's focus on the last information followed by substitution by an electrophile. Any electrophile will give you only one substituted product. What does that mean? The methyl group has to be at the para position. The para position is blocked. So this being an ortho-para directing group, right? The E plus, the electrophile would be oriented to the ortho and para position. Because the para position is blocked, it can only orient itself to the ortho position, giving rise to only one product, a mono substituted product, only one substituted product. Alright, that is how we identify A as para-toluidine. The name of A is para-toluidine. Alright.